Hello, this is my screencast for my assignment to design a 2D mobile game for my module 2D game engine development in my level 8 course games development taught by Derek O'Reilly. So starting off, I'm just going to go through the brief and I'm just going to explain what this is here. So the first thing I did when I was getting the assignment ready was I got the brief here, and first off I printed out the brief, took the brief from Moodle, broke it down into sections so readable for me, and then just broke it down into the separate parts that I thought were relevant. So these are just the main requirements with 10% and all that stuff. So after that, I could work on the stages of the assignment. So this is sort of like a step-by-step of what I should be doing, and it helped me to keep track of everything and how far along I was going and that sort of stuff. So I made this for the group. So as a basis for the game, what I wanted to do was I wanted to make a really good game, but I also knew that I might not have the time with other assignments and tests and things like that. So what I did was I broke it down into stage 1 and stage 2. Now this is sort of edited by the other group, but as you can see here, stage 1 is basically check off all of the requirements. Now, not to be confused with doing the requirements really well, but just checking them off so that I can get marks for each section, even if the game isn't done to an expert level that I would want to if I ran out of time. So here we just have all the requirements, which are just like listed here. This is just straight from the brief. Now, here it's just been edited by a member of the team, and this was even though it says requirements, this is more just like a step-by-step of like tasks, just check off lists just to go. In reality, we didn't really follow this too much. We more focused on these as guidelines, and that was just more of the same. So now I'll just show you the code. So to start off, I'll just show you my file structure. So the name of the file is called Game with Teddy. Originally, well, I'll get into that later, but it's just a site root, and I have all my images here, and I have all my files, and main files here are config, home, and index. So this is my index file. This is the first file that is opened up when you run the program, and so these are just my variables here. So I just declared all my variables. I declared these as I was going along with them, and then these are all of my images that I use. So I had an image for the background, the image for the actual player, the coins, start button, and a rock. And these are just for the variables for the functionality thing. So I'll just go through the code now. So first thing that happens is when the window loads, run this function on all assets loaded, which just says wait for Cordova to connect with the device and run the function on device ready. So when on device ready mainly just sets up the canvas and the some variables, like so these two are the variables for the X and Y position of the player to begin with. After this is done, then it starts the accelerometer watch. So the function of the accelerometer is it just gets the values of the change in acceleration so that you can change where the player moves every for an amount of time. For this example, I specified 20 milliseconds. So every 20 milliseconds, it's going to get the frequency array of acceleration values, the x, the y, and the others, and put them into the variable options. Now this here, what this means is that if the accelerometer was a success, so if the player moves, you want to run this function and put in the options. Whereas if the player didn't move, then you want to put this in. But in reality that was never really called in any of the tests that I ran. So we'll just focus on this. So on accelerometer focus, what we do here is we get the old x value and the old y value, and those will be needed later on. The first thing I did for the accelerometer was that when the player moves, I wanted to know whether the player ran into a coin or a rock, and that would that would affect the game. So you can see here that the width of the all the player, the coins, and the rocks, which you'll see later on in the game, are all 50 pixels. So this here was just to say basically if the player ran into the rock image. So this was just the rock x value, the rock's y value, the rock's and the rock's value was like for the x and y. So if the player ran into it, decrease score by 1 and run the function vibrate. And vibrate is just down here. Vibrate is just a function that literally just vibrates the screen for half a second. That's just to when the player runs into a rock. And here we are, and then decrease the score by thing. The way the game worked was that you were randomly generated in a place, and a coin and a rock were randomly generated, and you would move towards the coin while moving the phone. Just to give you a brief overview, and then when you collected five coins, then you won the game. So if you ran to a rock, then a score would be taken off you. So here is check for coin. So same logic here. If you ran into a coin, then you'd set up the count as 0. The score would increase by 1. If the score is less than 5, render the canvas, as in render a fresh coin and a fresh rock. And if the score was equal to 5, so you collected 5 coins, run the win animation. So we'll just go with render canvas then. This here was to and then after all those are there, you have to get the new x and y value. So this here is just what I was telling you about, the options that were called here in the frequency. So you had acceleration x, acceleration y, and then what you did was you just added them to the x and y value, and you multiplied x because you're inverting it. And then if these values here were just so that the character wouldn't actually run off the screen, and if they did, then vibrate it, stop them from running off screen, and then vibrate the controller so the player knows not to do that. And all of these functions were just to get the speed at which you're accelerating. So you want to get the distance from the current position from the old position, and if it's increasing in the x-axis, or if it's bigger in the x-axis than the y-axis, then you know he's increasing downwards or upwards. Whereas if it's increasing in the y or the y-axis, then he's increasing it to the left or the right. So based on that, you can get the spin direction, which I didn't actually use in the game, just because I just didn't like it. I didn't like the effect of it on the character, but there you can see the code for it. So if x is acceleration.x is less than 0, it goes anti-clockwise. If it's not, then it goes the other way. And if it's completely still, then it just doesn't move at all. So after this, then you render the canvas as well. So we'll just skip on down to render canvas. So for the render canvas, what I did was I separated the draw functions from the render functions. Now, this might be a tad bit confusing, but I'll go through it. So actually, render background is a bad example. So I'll start with render player. What I wanted to do was, because the actually I'll start with render coin. Yeah. So when you're rendering the coin, if you ran render coin every single time the player moved, then the coin was hopping around the screen like in any random direction. So what I wanted to do was I wanted to render the coin once, and then that would be for the first time you played it, and that would be count is equal to 0. After you rendered the coin and you rendered the rock, the two variables that were supposed to stay the same, then you would increase the count by 1, and then if it was, then you would just draw the same coins in the same spot. So you can see here as an example, render coin. what render coin does is it gets random values depending on the width and height of the x and y values, and then just calls the coin draw coin function, and then it just takes in these values and the width and the height of the actual coin and the coin image, and then it renders that onto the screen the same. Whereas here with the draw coin, it already has these values, so it just skips on straight into this and just puts it in the exact same spot. And that's how you keep the coins and the rocks, as you can see here, draw a rock and render rock and draw a rock in the exact same spot. Now back to render canvas. So then that was count, and that's how I rendered the canvas fully. Now I'll go back up to here because there was a second option. That's basically the full game dynamics. I also had a render background, which would render the background on top of everything, and that would did sort of cover up all of the past renders as well. And see if I can render. Yeah, so the run win animation was actually pretty fun to do. What I did was, instead of making a big flashy like fireworks display, what I did was I just, with this, if the player got 5 coins, then they would just call the function run win animation, which is down here, which all that would do would just be open up window.location home, which would open up the file home.html. Now I'll just get this for you here. It's in here, and home.html is just a file that has winner in it, and then it has a button, so that when you actually click on the button on the screen, it's with a value of replay, then you can replay the game. And that you can see here, on click load function, and load function will just bring you back to the index, and that will bring you back to the start of the index, so that you can replay the game if you want. I also have some JavaScript DOM programming here. The winner function here was supposed to turn from blue to red over a time of like 2 seconds, but it didn't end up working. But so there you go, I ran out of time on how to fix that. Now I'll just run back over here so one last time in case I forgot anything. Draw image. No, I think I'm good. That's just where the canvas was rendered. That's the vibrate function. That's actually, yeah, that's where I got the vibration. Oh, and yes, one last thing. I did try to incorporate some media sounds into it, but it just was not working for me at all. So I have var media is equal to new media and the location of the file, which is right here, and then I would say media.play, but it was not working. The reason it's commented out was it was breaking the program. Last of all, I'll just go into the config. The config is just your general stuff, and at the end here you can just see my plugs for media vibration and device motion. So that's basically all the code. That's how it all works. If you want to see my file structure here, you have my index file, my icon for the image, the home file, the soundtrack to config file, and these are all the images. Now I didn't actually use all of these images, but they are here all the same. After this, let's bring you back to here if you want to see. Now see, this penguin character here was actually my original character. Originally I decided I would just use a normal character instead of using the teddy bear, and then if I had time later on I would import the teddy bear, which I did. So going through the requirements, I'll just tick these off then, I suppose, as a last thing. So the game does work on an Android, Apple, or Windows. The game is original catching thing, incorporates touchscreen, click, and swipe features. It does incorporate click, and the sound of them, I did try to do that, but it didn't work out as planned. The incorporate 2 mobile devices other than touchscreen. The 2 mobile devices were accelerometer and the vibrate. Professional finish, that's the win animation. Collision test, that's for the rock or the coin or the sides of the actual field, or the waves, or the actual phone if you wanted whatever you want. Collision test from gravity. Gravity wasn't a huge factor in the game as you're constantly moving up and down depending on thing, but it was still there. Good coding practice, well, that's for yourself to decide from the code. And published on Apple. Yes, I do have this published on the Apple Store. and this is the screencast right now in the bitbook I'm working on at the moment. So I think